right, we are on week 4, day 3, and we are continuing to learn about classes this week. We've kind of had a basic introduction to classes so far. We're piling on a little more things each day. Let's go ahead and start getting a few classes together here on the screen. Today we're going to start learning about inheritance in classes, and we're going to kind of look into why we use inheritance by just setting up a couple of I guess job title classes. Let's say we're just trying to make some classes for different employees that we have in a business. So as we reviewed earlier, we define a class by saying class and then the name that we want to give this class. Let's go ahead and make like a programmer employee. Okay. And this all you can follow along with in the README, and then we're going to go over an extra example at the end. But I have this programmer class. With every class we make, we also want our init method here to be able to set up different instances of this class. And we start with self, and with this programmer, we want to be able to pass in their name. We're going to have an employee ID, department, and languages, computer languages known. And of course, we know that we have to do self.name equals name and the like on the same time, and just copy this directly from the README because it gets tedious entering in all those. All right, now I have another employee, not a programmer. This employee is an accountant. Totally different person. So I'm not going to be in different attributes associated with them. An accountant doesn't know programming languages, right? So I'm not going to use this class instance for them because they don't have any languages they know for programming. So accountant, completely different class that we want to set up here. So we're going to make ourselves an accountant class now. This will be great. Then I'll have another class I can initialize over and over again, create different instances of different accountant employees this time. Still going to have our initialization method here. Oh, and look, VS Code was so smart. If I just did that in it and tab, it actually filled in for me here, the self, and entered down to the next one, which is great. But I do want to pass in some attributes to this. The accountant, they also have a name. They're also going to have an employee ID. They're also going to have a department they work in, except they don't have languages. We already knew they're not going to have a computer language. Instead, they have some sort of certification to do their accounting job. So I'm going to copy this from the README again, because we understand we have to assign these to the instance of the class that we're defining here. And so now this looks great, right? Or is there a problem here? What's one of the first things that we learn when we're coding something after we finished writing a full page of code? What's one of the things we want to look back on and make sure we're not doing in our code?
Duplicating?
Duplicate, right? We don't want to repeat ourselves in our code. If we're repeating ourselves, we are being inefficient somewhere. There's no need to duplicate work over and over again. So where do we see duplications here?
Did you not have to initialize like employee ID or name or department again? Could you have just taken that from the other?
That would be great. That is exactly what I think I want to do. However, at this, like this, how we have it laid out right here, I cannot just take from this class right here. I have to, each class is its own thing, own object with its own attributes that we're defining. But that is exactly the issue we have here is we have name in both. We have employee in both. And we have department in both of these classes. So man, there's a lot of repeated attributes between these two classes. How we can handle that is we can we can inherit from another class. As it stands right now, I'm not going to want to inherit from programmer because I mean, there's things in here that I don't need, right? There's languages, there's some other things that aren't really going to be applicable to other employees in this company. But let's go ahead and create just a generic employee class. Okay, doesn't have to be a specific job within this organization. Oh, when you have tabs. So here, I'm going to create a basic employee class. Oops. We're going to have our initialization method. Okay. So now, looking between these two, we already identified that name, employee ID, and department are shared between these two. And I anticipate if we add in like the manager, he's also going to have a name, employee ID, and department. These three things pretty much seem like they'll be with every employee within this organization. So for a basic employee, every employee in this organization is going to have a name, employee ID, and department. This is going to be a given for everybody that joins our company. So I have this basic employee class that goes ahead and grabs all this information for us. Now, I want to figure out a way to be able to use this class with these. So this is where we do our inheritance. We can base these classes off of a different class. So these are going to be subclasses, and we are going to base it off of a base class. So employee is our base class. This is the most basic we can get that everybody's going to have. And in order to inherit everything that comes from this class, we're going to put parentheses after the name of one of our classes and just throw basic employee in there. So now when I do this, I have access to this class. It's inheriting this structure of this class, but we can't just automatically grab everything like we think we can. We have to do something called a super initialization. So this might be a little weird and foreign at first, but it follows the same structure pretty much every time that you're doing this. We're still going to have name, employee ID, department, and languages because these are still attributes that I want in here in this class. So when I initialize a programmer class, I want to still be able to pass in name, employee ID, department, and languages. But because I'm inheriting from a base class, I don't need to define these again because this base class already does that. This base class has already defined them and basically attached them to that instance of the class. So I can take these out. Oh, not the languages. Sorry, let's go back. I could take out these. These are already defined. But in order to tell this class, because now see, they're grayed out again. It's like, wait, I don't know them. Where are they coming from? In order to tell this class that these exist elsewhere within basic employee, this is where we do our super init. That's what I meant. Thank you. And in our super init, we say we're taking name, employee ID, and department from the super class, which is going to be this class here that we passed in, which is our base class up here. So we kind of see how this works, where we leave our initialization alone because we still want to pass in all of these parameters to this class, all these attributes. But instead of assigning these attributes to self.name, we just go ahead and say, hey, we already did that in this class up here. Go ahead and use that structure to initialize. Okay, so now somebody take a stab at how I can change accountant to go ahead and inherit this. The only thing this is really doing is changing how much we have to write under each of these subclasses. It's going to act the same where you still pass in all the same attributes, and it's going to instantiate an object with all these attributes, but you just don't see it defined explicitly underneath this one class. But yes, okay. Who wants to try changing class accountant to inherit from basic employee?
So I would just copy line 12, and then paste that over lines 18 through 21, right? Because we don't have department in accounting. Oh no, yeah, through
Okay,
line 21. Yeah,
got it.
18 to 21. And then leave line yeah.
Okay, this is good. I'm missing one thing. In order to be able to call this super
Oh, you
class,
got to put basic employee in accountant. Yeah, you got in the parentheses after accountant. You
exactly.
need to put basic employee there.
This is so we can tell where for that super initialization to look for those definitions. Perfect.
So if is there a situation, and I guess maybe not if it's going to be like a base case there, but if we didn't want to inherit like employee ID, it would be something as simple as like in line 18 for the class accountant, we would just delete employee ID from that, and we would that wouldn't cause the function to break or anything. It would just not pull it in. Does that make sense?
Yeah, if we didn't want to include employee ID, we'd also have to take it out of our
Right.
initialization as well. But yeah, this is
But that
perfectly
wouldn't break
fine.
it. Okay.
No, because we can inherit things from this class. We can inherit one thing, two things, three things, or everything. You don't have
Right.
to take, you have access to everything in here, but you don't have to use everything. Exactly. Okay, so let's see this in action when we go ahead and I don't like getting into the Python terminal. We're just gonna put these as lines up here and just run this program. Let's see. Oh my gosh, other screen. So we're going to go ahead and make a programmer. Um, this is CP grad. In order to basically instantiate an object, we have to assign it to a variable. We can't just call programmer with all the attributes, right? Because then it doesn't really save anywhere, basically. The object has to be assigned to a variable, especially in order to use it over and over again. So this code platoon grad, we're going to make a program. So how do I instantiate an instance of this programmer class? Do we remember?
So you're
Yeah.
gonna
So sorry, go ahead.
put programmer and then parentheses, and then you're going to fill in what those attributes would be. So
Exactly.
yeah.
Sorry, I didn't mean to cut you off, but you were correct. I was just want to point out that like most of the functions we've worked with, if you hover over, you can see every attribute that this expects us to pass in based on how we define this class. You can see that it expects a name first, then an ID, then a department, then languages. So that helps you kind of figure out what you need to put in these parentheses. It's just like a function when it expects parameters. So programmer expects a name. We're going to give it, let's see, you have to format it correctly. If you're passing in a string, you have to put it in quotations. Appropriate data types you have to pass in appropriately, or you have to pass in the correct way. Again, the tiredness is making words hard tonight. Okay, so we got a string for our name is Bob, an employee ID. This is probably just going to be an integer or the like. So we're just gonna put in some numbers. We don't have to put that in quotation marks. Department, again, gonna be another string value here. So let's programmer, they are in, we're gonna put them in reliability because that's where I work. And then languages known. This, I'm actually going to give a few things. I'm not just going to give one because I know many languages. So we're going to, well, Bob knows many languages. Bob's the employee here. He works in, we're going to say he works in Java and he works in C#, and he works in Python. Awesome. So that should be everything this expects. We have name, employee ID, department, and languages. And now we can see it tells us how we've, before it said any next to all of these attributes, but now when I've created this object here, basically, when we hover over it, it shows us the data types we're passing in here. So now we can see string, integer, string, and list. So another little fun tidbit there. Okay. Really? Does it have us just print it here? No, we're going to, I guess we're going to print CP grad. And how do I target different attributes of this instance of the class?
Using dot notation.
Correct, dot notation. Gotta love it. So easy. What do we target? Do we dot and then like try to grab an index, or how do I, somebody explain further out? Baby programmer here, tell me from scratch. What do I need to target? Like, let's say I want his name.
It would be dot name.
Okay, so we're gonna print his name. We're gonna print everything. Employee ID. Nah, we're just gonna print that. You'll get catch the drift here. Okay, so I'm gonna run this. And we can see it did indeed pick up Bob and 1, 2, 3, 4. So now, before I get out of here, this is where we'll go back into the string methods that we can put underneath these classes. I'll show that real quick. Let's just try printing CP grad and see what it does. What do we think this is going to do?
Going to give you the address that it's pointing at
Yeah.
or located at.
But for those who might not know what that means, it's just giving us where this is stored at. I guess in the computer? I don't know. But this is not helpful. It's just telling me I have an object at this location, right? That's not helpful at all. So that's weird. I don't want, if I call or print this instance of this programmer, I don't want to see just, hey, you have an object. I want to see like this guy's name and his employee ID and all that. And I want to do it without having to print dot name, dot, all that stuff. That's a lot of work. I just want to say, hey, print CP grad. So what we can do is we can come up. So this is the instance of programmer. Let's come under here and we can make this string method. And what the string method does is every time, turn super string, take that out. Every time we call this class or an instance of this class, instead of printing out the object and the location, it's going to print out whatever we tell it to right here as a string method. So let's just play with this and see. Let's see if I can we're going to print out self.name and self.department. And I haven't double checked my syntax here, so I don't know if I'm missing anything, but best way to know if it's working or not is just to run it and see. Oh, look at that. It worked. So now when we printed it, I didn't do anything different down here. I'm still just calling, printing out this object, this instance of the class. And I'm not targeting name or department, but yet it still gave me his name and department because of this string method I put underneath this class. So that is how we use those string methods to kind of help visualize our objects instead of having to target specific attributes within the class. We can just go ahead and throw it in a string method. If you know you want to return the same thing every time you just ask for that object. So I would do this especially for employees because if I want to print out an employee, I just want to be able to print it and see everything associated with that employee. So I'd probably actually throw in more in the string object, but very helpful feature. If you ever want to just call the instance of the object you've created, have a string method. Just get used to throwing it under every class you make. It'll make your life easier. Any questions on everything we went through so far about inheriting string methods?
If you printed CP grad as an accountant, would that work?
What, I'm not
So
sure.
because we're missing employee ID and accountant, would that still work missing one of those parameters?
So if we change this to be an accountant and I don't have an employee ID, and then we're gonna pass in certification. Well, I don't know why I did double quotes on that one. That's weird. Oh, what kind of I don't know. An accounting certification. I don't know what they get. Let's see what it gives us. Oh, but I don't have a string method. Let's create one of those real quick. What would be a good thing to put in the string method here? Anybody?
Put the same thing if you want it.
Yeah, put the same thing. We can put everything here. Let's self.name. This is tedious to set up, but it's worth it when you can just print everything all at once without having to grab it specifically. Self.certification. Okay.
I'm curious, Tiffany, if you put that under string method in the basic employee method, would it work for all the classes that are using it?
They don't under methods get inherited like that. I would assume they would. We're gonna see how methods get inherited in another example in a minute.
Okay.
Method inheritance Python. We're gonna look at that real quick. Yeah, they're inherited just fine. So we can do a string method up here and it'll inherit it in lower classes. We'll play with that later. Let's go ahead and follow through with this thought and then we will get into another example kind of going into that. Okay, so let's print this and see. Missing department. Yeah, what am I missing? Name, department, certification. Superintendent name and department. I thought we can not take everything from the first one. Is that what you're trying to point out, Justin, that we have to take everything?
Correct.
I thought there was a way
Because I
around
think
this.
it goes parent, so parent being A, programmer being B, and accountant being C. It goes up the chain, so C goes to B, B goes to A for inheritance reasons.
Yeah, maybe let's see, we'll have to look into this here. Because I know when we do methods, it will look within the child class first before it goes up to the parent. This gives me the answer I'm looking for. So if the parent's init is not called, the child class will not inherit all attributes initialized. Unless they are defined outside of the. So it says it inherits all from its parent class by default. However, it's not mandatory to use or directly access all inherited attributes in the child class. So I'd have to figure out how to. I can look into this more on how we can not use everything from the parent class. Same name effectively replacing, that's overriding. We're doing that Saturday. Or no, we're gonna do it here. Correctly as if they were fine. Probably just have to take out the super.
Tiffany, try taking out, so just take out name and department.
From super.
Yes, from super, and then try running it.
Yeah, well, then we don't have, no. Okay, so with that, basic employees requiring name, employee ID, department, but we got those. I'll have to look into this. That's a special case. Usually you do inherit everything from the original class, otherwise, but I'll have to look into how this is not mandatory to use or directly access all attributes. So I'm leading you all astray. Sorry,
I think in basic employee, if you set employee ID equals none, department equals none, certification equals none, you can then do
like
that.
by default.
Correct.
Right.
Yeah.
Right.
Yeah. Again, it's a special case. So it can be done, probably shouldn't be done if it's this hard to do. If you're not inheriting everything, then I guess you got to ask the question on why am I even trying to inherit from this class to begin with?
Right.
So there's ways to do it. Y'all can look into it. But good call out there, Justin. If you want to stick with the syntax that we've been going over that's familiar, you're going to have everything from the parent class in here. And we understand this now. Otherwise, like Justin said, you probably can pass in. Why is that being weird now? Is that spelled wrong? Probably can pass in none as a default value up there. But oh my gosh. Is there something wrong? Do we see something wrong?
It's not in your init.
Oh, yeah. Okay. There we go. And then I would have to pass in an employee ID. This one's gonna be 5, 4, 3, 4, 3, 2, 1. Okay. But now we can see it printed out there. Bob, reliability, accounting. Okay. I guess let's do the inheritance of the string as well. Let's say we don't care about the certification and all that. I'm gonna take this out. We just care about name, ID, and department. So we're going to put a string method up here. And we're just going to have, and we'll just throw the ID at employee ID at the end. Okay. So now, actually, we're gonna get a little, we're gonna try something here to kind of illustrate what happens when we pass methods down or inherit them from our base class here. So I'm gonna leave this string method for programmer. We're gonna change this back to programmer. And we're just gonna leave accounting, that's fine. This is for demonstrative purposes for his languages, I don't care. So now if I were to print this programmer, what do we think we'd see in the terminal? Oops. What is your first instinct on what you'd see?
You would see you see Bob and his department.
Okay. So your initial instinct is that it would be this string method right here.
Yes, because it's overriding the parent string method.
Okay, cool. Did y'all learn about overriding methods in, nope, you just know Cisco? Okay,
Mhm.
so this is what I kind of said when Justin and I were chatting about this is if you have a method with the same name in the class that's inheriting from the base class, this subclass, it will first look within its own class for the method. So if it's like, okay, I gotta do a string method here, it's going to first look within itself. If it can't find that method in itself, then it will go up to the base class and look in there. And it'll say, okay, I see a string method here, I'll use this one then. So we are expecting that we should see this string method first when we run this. And we do. This one took precedence because it's in its own class. But if I were to name this something else, well, we'll just comment it out. If I didn't have that and I run this, it's going to do the same thing. It's going to look in itself and say, oh, I don't have a string method. Let me go up to my parent class and look in there, see this string method and use this. So now when we run it, now we see the full name, department, ID. And this will be true with accountant. I'll be able to run accountant and it will look to the parent class for any methods we've identified. What is a method? We're talking about attributes a lot and now I'm throwing in methods. What's a method?
A function within a class.
Yes, yep. So any function I define within this class, we're going to call it a method. And so that is what I mean when if you run a class or an instance of a class, any methods, it will look within itself, then the base one, the parent it's inheriting from. Awesome. Okay, so now we're going to go into kind of a different example to kind of throw together everything we've been learning about so far. Any questions on this? How inheritance works? Okay. We're gonna start fresh. Now, I'm gonna kind of do like an Amazon shipping. Some classes that I could use with Amazon shipping. I want something where I can make boxes containing like different products that you have in there. But I'm gonna have the regular box that I could ship out, but then I also want like the gift box where you can put it in the fancy wrapping and have the gift card with it and ship that up. So when we're trying to think of inheritance and classes and how we're going to tie them all together, let's think about the situation here and try to figure out what might be like a common denominator between I'm wanting to make like boxes and gift boxes and the shipping out. What's kind of a good common denominator that will be true for both of these things? Let's just think about it. What's something that's shared between a regular shipping box and a gift shipping box? Oh, Cisco muted.
Yeah. A box.
Yeah. I mean, they're both going to be a box. Okay, that's a good idea. We're just going to comment. We're going to pseudocode here for a minute. Just throw some ideas out. They're both going to be a box. Are they going to kind of act the same? I don't know how to prompt for this. I'm kind of thinking like there are going to be things in both these boxes, right? It's going to be the same between both. We want Each box is going to have things in it. Cool. That's the same for both. When I ship this out to people, these boxes, and I'm shipping them out, what are they going to have? What's kind of shared between the two of them? Like if I get an order from Beth and she wants a box containing this stuff, and then I get an order from Joe and he wants a gift box containing this stuff. Kind of an abstract way to think about things, I guess. But
Got an address or shipping label?
yeah, we're gonna have a shipping label that's going to go to a person. We're gonna dumb it down. In reality, yes, we want like name, address, and all that sort of stuff. That's gonna be the same on all these boxes, whether they're gift or regular. But for now, we're gonna say they're gonna have an owner. And that will kind of portray a full-on shipping label. So these are gonna have owners, or I guess buyers, whatever we want to call them. Great. Let's see, anything else that might be similar between the two boxes? Trying to think, we can start like creating our classes and then seeing as we go, maybe as well. So we'll start with just our box, okay? A basic box, because to me it sounds like they're both gonna be boxes, have things in it, and have an owner. And that's kind of true with the plain box and the shipping box. In my head, I'm thinking shipping box probably has some extra things to it, right? That maybe the regular box doesn't. So let's just make a regular box first. We're gonna make this class box. Oh gosh. And then, oh gosh, what am I doing? And then we need our initialization method, right? Yes, Art.
We saw an example. We were dealing with canines. And they said, well, what are the common things with canines? And like they're like, okay, they all have four legs, or they're all canines.
Mhm.
And so we had variables that were sitting on top of the class because we knew if we're dealing with dogs,
Yep.
they're always going to have four legs. So when is it appropriate to put a variable outside of the class?
So that is a great question. That's the class variables I kind of touched on. Like if you don't understand, don't use them. You can get around using them. But like you said, it's something that's going to be true for every instance of this. So if I'm thinking of boxes, I could think, I mean, a package that has four sides and like is in a square, that's my box, right? That should be true across the board. So I can make that as a class attribute. However, sometimes that box might look more like a rectangle or it might be circular. So if there's any variation in how these boxes are going to appear, I can't have that as a class attribute, because when you change that class attribute, it's going to change it for every instance that you've defined. So if I make a box instance and let's say we've got it set like, I guess box equals square. And if I initialize this, I have box 1 equals box, and then pass in whatever. And then box 2 equals box. Both of these boxes are going to be square. If I decide, actually box 2 doesn't fit in a square, I need to put it in more of a rectangle. If I were to try to change box 2's box equal to like rectangle, oh, it's capital. My bad, don't yell at me. Into a rectangle. Because this is a class attribute, when I try to do this, it's going to change it for every instance. So now box 1 will be a rectangle as well. Actually, I don't even know if you can do it this way. I actually don't know how to, let's see.
You're right.
Okay.
But so box 2 will only change box 2's instance. It will not actually change the box within the class.
So changing the class, that's what I'm trying to like,
So you want to do box. You want to do the class and then dot box.
okay.
Yeah.
So this one even work because it doesn't, no, that's not how class attributes work. I shouldn't be able to do this. This class attribute is going to be the same for everything. I can't make it unique to the instance. That's the point of the class attribute. So this probably wouldn't even work. I'd have to refresh my memory real quick on how to target the class attributes here. But doing this works because that's a class attribute, so we can target that. If we had in our init a box, that would be confusing for this, I guess. I don't know if that would work then. I don't even know if you can have an individual instance attribute the same as a class attribute. But the class attribute is going to be across the board. There's no identifying between different instances, if that makes sense. So there's, in no world can I make box 2's box a different shape than every other box out there if we do it like this. So the shape, not a good idea for this. I would likely put that as an instance attribute, something that can change for each individual instance of box that I have. I will have an example of a good attribute that we do throw on this class, but it's not going to be what you think. So let's flesh this out a bit more. So for each box, for our initialization, how do we want this box to look when we get it? We figure it's going to have things in it. Does it have things in it yet? No, I don't want things in this box yet. I haven't packed it yet. I just want a plain box. I just want a box that I can do things with. However, if somebody orders stuff, they're automatically going to get a box. So I could probably give it an owner of that box right away. Could, don't have to, just an idea, but let's leave it blank. I don't want to pass anything in here. But we do want to be able to put things in it. So I do want to have an attribute in this box that I can change and do things with, basically a variable that I can store things in. That I don't have to initialize with a value, but is there for me to use. So that's when we come down here, and I'm going to just make like self.contents. Okay, now you have to have it equal something. Since I'm not passing in any value for this attribute, what can I do here? What do we think I can do? I want something that can hold items for me. What's a good data type that can hold items? Let's go simple. Don't get fancy on me. Huh?
A list?
A list, perfect. Yep. So do I want to pass in a list with anything in it, or
Just an empty one.
Yeah, just like we do with a lot of our algorithms and functions. We're just defining a list that we can throw some contents into, but it's going to be empty. It's just there for us to use later if we want. Because we haven't packed a box yet. We're not filling it yet. We're just making a box. We're just setting up a box, an empty box. Now, one thing that I'm going to throw in here is this class variable I'm talking about that I want to have with this. Since I'm Amazon and I like to know how many boxes I'm shipping out at all times and know how much money I'm making, I'm gonna go ahead and make a box count variable. Attribute, class attribute, sorry, we're gonna get the correct terminology here. So now I have this class attribute. That's the same for all boxes that I could ever make ever. But it's not a big deal because this is kind of more of a tool that I'm going to use to track how many boxes I'm sending out versus something that's unique and individual for each instance of box. This is going to hold like all boxes we create for all time. So that's why I'm making it a class attribute. Because I want it to see every instance we make, and I want it to be able to kind of keep track of all those instance values. So now, every time I make a box, when I initialize this class, every time I make a box, I want this to go up by 1, right? I want to keep tracking how many boxes I have. So in my initialization method here, I'm just going to target that box count, and I'm going to add 1. So then every time I initialize a box, it's automatically going to increase this class attribute by 1, which is what I want it to do. I want it to track every single box I make. Cool. So does that look good? We think we're good? Simple, easy. I just want to set up an empty box for us to use. That's pretty good. Let's think about other things we're going to do with this box. So we've set up an empty box. That's our initialization method, right? We're setting up an empty box. But we want to be able to put things in this box and then ship it out. Is this the putting things in it we've defined as something that's probably going to be an across the board type thing. So I'm going to put it in this big overarching class, I guess, for lack of a better term. So let's make a method. We're going to make a method here to add items into this box because this box can't do anything unless if we make methods. It's an empty box when we initialize. Unless we make methods to do things with it, it's just going to stay an empty box forever. So I'm going to make something that's going to add items to this box, and I'm going to label it specifically as an add items method. For every method I make under my class, what has to go in here? What's the first attribute I need to pass in every single method I make in a class?
Self.
Yes, self. Even if you're not passing anything else in, always self. Get in a habit, throw self in there. Self's the first thing, always. Okay, so do I just want to pass in self, or do I want to maybe do some other things? If I'm going to be adding items to a box, what else do we think we need? So we've got this empty list here for the contents of the box. And then I'm going to make this method to somehow put things in this empty list. Right? That's going to be our putting things in the box. Can I just call this method with nothing in it and expect this list to increase in size? No. All right, so what should I pass in as another parameter for this method?
Content.
Yeah, we can name it contents. Let's do that. All right, so now I've got this item, this contents that I'm holding, and I want to put it in the list, my box, my empty box. What do I need to do now? So the pseudocode is put contents in this is in the contents of box. Of this box, I guess. Okay.
Well, first, don't you have to initialize contents?
So no. Why do I not have to initialize contents?
Because it's already initialized.
Oh, I
Where,
missed that.
well, so let's rename this. This is gonna get confusing. Item. I'm gonna put this as item.
Mhm.
Put item in the contents of this box. So looking at how we've got this kind of going so far, yeah, I'd expect if I want to be able to do things here, I need to initialize an item, but we don't need to because this is just a function. This is a function we're going to call and we're going to give parameters for. So we don't need to initialize that in this class because it's not part of our box. It's something we're going to be doing to the box. We only initialize things that are part of our box. And we've already initialized an empty list because we're going to have a bunch of items or maybe one, but that's where we're going to hold these items. So items that are part of the box, they're just going to be within this contents that we've already initialized. So I guess the answer to your question is yes and no. Yes, we had to have somewhere to put it, but we don't need to initialize item because we already have a place to put the items in. Okay, so now let's get back to programming logic here. How do I add an item to that self.contents? How do I add an item to a list in Python?
.append.
Yes. So you can just do self.contents because that's saying, hey, grab our specific instance of contents and we're going to append the item. Perfect. So that's all I need here. Anytime now I call box.addItems and pass in an item name, it's going to put that item in this contents list for us. And it will just store it in here over and over again. Okay, what else do we need? So now everybody has an owner. I should have passed that in up here then, because we said everybody's gonna have an owner. Let's just add that just to tie up loose ends here. Self.owner equals owner. Okay. Notice I don't need to put these in order in case you were wondering, because we've identified where these are coming from. But when we pass in our parameter or our attributes when we're initializing this, we do need to put them in order. Okay. So I think, let's see, we also got to, let's make a like prepare for shipping as well. I mean, just because that also is going to be something we do for every box. We're going to prepare it for shipping. And again, we put self in here. Okay, so for this, we're just going to return an F statement. Just to say, hey, we're making this box. So this is a standard box. I'm just going to go ahead and say, let's go ahead and target the owner. Hey, Bob, your box has been packaged with bubble wrap and placed in a standard box. Okay. So now we have adding items into the box, and then we have getting it ready to ship to Bob or whoever's buying this. All right. Now so I have this box count and I have it incrementing here, but I have no way to see this box count besides just, calling the specific attribute. I don't want to do that. I just want to have kind of like a nice string method. to be able to see how many boxes I have. But since this is a class attribute, I can't write it the same way I've been writing every other method that we have here. And it's not going to be a string method because I don't want this to print with every time I call just the box instance. I just want to be able to say, hey, give me the box count. So how we do class methods and identify them is simply by calling it an @class method. This is telling Python in the class that what I'm about to write here is for the whole class and not specific to each instance. And here I'm going to write like a total boxes. And now what do I pass in here? We've been passing in self every time, but self is for the specific instance that we create of this box. I'm not targeting this instance, I'm targeting the class. So what do we think we put in here?
CLS for class.
Yep, CLS for class. Did y'all learn that? Are y'all cheating? Hopefully we learned it already. Okay, so now this method is going to look like a string method, kind of how like this did, but it's specific. It's not just going to be called by calling the instance of box. We're going to actually call this method print total boxes. So we're going to return the f string of total boxes created and just pass in. Now, how do I target box count? It's a class attribute. How do I target that? We've already established I can't use self.
Going to be class dot box count.
Class.box count. Perfect. All right. So this looks good. I have, the only thing I'm missing is a string method for box. We could do that. I don't really feel like the need right now. I'm not going to just sit here and call boxed instances and show me what's on the screen. If I wanted to do something specific for the instance, I would probably do more like a show box contents and have it, you know, print out what's inside the box. But we're not going to do that to save time because I don't want to take, I know I lecture for very long, so I don't want to take up too much of your time. All right, so we have our basic box. Now, we're going to make a gift box. If I didn't use inheritance, I would have to do all of this all over again. And I don't want to do that. That's a lot of typing. That took us a long time to make. So we're going to inherit from box, right? Because a gift box is going to do all of the same things that a regular box can. It's just going to have some extra stuff going on. So let's make a gift box. This is inheriting from box. So we are going to put that within our parentheses there. All right, so now we need our initialization method. How do I make an inheriting initialization method? Oh, look, VS Code is so smart. It helps you cheat. So since we inherited from box, it already knew we're going to need a superinit to go ahead and grab all the attributes we've already established up here and all the methods. So with this one, and it already brought in all the things that we need to pass in as well. So very lovely. I do want to add in another thing though. So when I make a gift box, you know, on Amazon, you can type out the little personalized message for the gift. So I'm going to add a message. People can add a message to their gift box. Okay. So since that's something new, I have to add that down here. Self.message, not that smart, is going to equal the message we pass in when we instantiate this class. Okay, so now what else is different? I mean, it's pretty much gonna be the same. We're gonna add items. We're gonna prepare for shipping, but I don't want to use this prepare for shipping that just puts it in bubble wrap in a standard box. This is a gift box. I want it to be fancy. So automatically this gift box will inherit this prepare for shipping, but we can overwrite it because I don't want it to behave the same way that the base class does that we're inheriting from. Every other thing I want to act the same way. I want to be able to add items the same way, and I want to print out total boxes. But this prepare for shipping, I want to change that up. So it tries to be helpful. No, thank you, because I'm going to replace you. So we've got our prepare for shipping for this instance, this gift box, or this class. I'm going to return also another F string, but instead of putting it, you know, we're just going to copy this. Instead, we're not going to put it in bubble wrap. We're going to put this box. Your box has been packaged in fancy paper with a ribbon. So pretty. So now whenever I initialize a gift box and call prepare for shipping, it's going to look here first, find that, oh, I have my own method to prepare for shipping, and do this. And then it won't even look here. It's not even going to see this one. All right, so I think this looks good. Now, theoretically, gift box, I should be able to, it should, when it initializes, it should increase my box count by 1 because we've got that going on with our base class here. It should be able to have items added in it. And I should be able to still call total boxes to check, you know, how many boxes we have so far. The only difference is now I can do a different shipping and I can add a message to it as well. So let's start setting up some of these objects to kind of see this in action, and then we'll be done. I promise. It's getting long, I know. Okay, so box 1. That's just going to be a regular box. So if we see the only thing we're passing in box 1 is an owner. So let's say this is Bob. Again, Bob ordered just a regular box. He's shopping on Amazon. So he's throwing things in this box. So he's going to start adding items in this box. He found a book he likes. So he's going to put a book in there. So now let's take a look at this. Can I just go ahead and, you know, start making a list and throwing a whole bunch of things in here? Let's see, TV. I might add a whole bunch of stuff. Can I do this? Let's look back at our method and see what it's doing. So we're taking in an item and appending it into this list. So I could start throwing a whole bunch of stuff in here. Of course, I'd have to wrap it in a list if I wanted to have multiple things. But that's going to put a list within a list because that's where we told these items to go. So function, like how this is going to function is every time he clicks add to cart, it's going to call add items with that one item. So if we're going to add a TV, it's going to add to cart. We're going to add that TV. So it's going to call that method over and over and over again to put them in this list. All right, so now after he's added his items that he's got, we're going to go ahead and print our prepare. Let's see, we're going to print that prepare for shipping to see how it's being packaged. What am I missing here though? So I've got this box. I'm going to call the method that we have identified underneath it here. Well, yeah, in the standard box. Does this look good?
The parentheses.
The parentheses. Yes, anytime we call a method, function, what have you, you need to remember, not 90, your parentheses. If you don't add those parentheses, it's going to think this is an attribute in this class and try to target a value in an attribute, which doesn't exist. So here we're going to, I don't even know why I'm printing this. My brain is starting to die here. I don't think I have to print it since it's returning an F statement. All right, so we're gonna prepare for shipping and we're gonna see his box packaged in regular stuff. Let's try it. Oh, well, it did not print it. So it's returning an F string, but I guess to see it in the terminal, we still need to print it. There we go. All right. So it created an empty box assigned to Bob. It added a book and TV in there. If we had written the show box contents, I probably would have, had that method called here to print out what was in our box. But we don't have that. Instead, we have prepare for shipping, and it says your box has been placed in bubble wrap in a standard box. Cool. Let's make our second box now. And this one's going to be the gift box. This one's going to go to Nancy. Let's see. So let's add some items into this box. We're going to add a cat. And we're going to, that's fine. She's only getting a cat. You can get anything from Amazon. So now we're going to print our, what do I call it here? B2 and our prepare for shipping. We're going to call that method. So I've went ahead and identified it's a method. And now I should see both of these because I haven't commented anything else out yet. B2 message. Oh, thank you. Thank you, Terminal, for showing me. I'm forgetting something. If we come back and hover over gift box, it expects an owner and a message because we've told it it's fancy, it needs a gift message. So surprise. We won't see this anywhere because we didn't account for it. We could probably with a message. Let's just throw it on here real quick. And this is going to be self.message. Okay. Now let's run it. There we go. Can you see that? I know it's at the bottom of the screen. So we have Bob has had his, regular box. Nancy, it's been put in a fancy box with this message that we put in there because this method overwrites the base method. Now, what else we can do? We have this box count. So every time I initialize a box, that should be incrementing. So if I come here and I go ahead and add a print, we're going to target the class, total boxes, and now it's a method. Remember, we made a method. So it doesn't take anything in. There's no parameters to pass in with it. We just call this method and it should give us how many boxes have been created. Because each time we create a box, it increases our class attribute by 1. So let's see. Perfect, it worked, yay. Total boxes created, 2, create. Wow, typo, that's fine. So each time it made a new instance of the class object, it incremented that class attribute we had, and we are able to access that attribute thanks to our class method that we created. And that was it for my extra example. Any questions of anything we've gone over so far? You will be seeing all of this again on Saturday as we do more inheritance, but in different ways. So this will be a lot of rinse and repeat, hopefully so y'all can grasp things better. But any questions on what we've went over so far before I stop recording and we go over our assignments for the evening? Nope. Alrighty. Oh, come on, where's my bar there?